Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our D programming language series. In this lesson, I'm going to show you something that's quite neat in the D programming language, and that's the pure keyword. Now, for those of you coming from a background from, say, Haskell, you might be familiar with this language, or one of the reasons that you use it is because it's a purely functional language. So this idea of function purity is really important, especially when it comes to writing multi-threaded programs where you want to avoid things like data races. But it's also part of the contract or the interface to the user using your functions to know what is and is not changing. So with that said, let's go ahead and dive in on the deprogramming web page here, dlang.org, and learn a little bit more about pure. So there's two ways to get to this. You can go to the language reference here, and you can go ahead to attributes, which I'll open up in one tab here, or functions, which I'll open up here in this tab. So if you go to the attributes, you'll see that there's various attributes, some which we've looked at here. And if I go to the pure one here, it's just going to take us to the functions page. So we'll just go ahead and hang around here. So what we want to do here for pure functions is we're going to look at section 4 currently and look at pure functions. So what is a pure function? Well, pure function, again, is something that cannot directly access global or static mutable state. So something outside of our actual function. We don't want it to be changing the behaviors of our program. This gives us more guarantees about our program and sort of its safety, that we're not changing data that could be changed elsewhere or in some other shared state. And pure functions additionally can only call pure functions. Otherwise, we'd sort of be tainting the data. So let's go ahead and take a look at this, and we'll go ahead and check out this example in a moment. But let's just play around with some functions here. So what I'm going to do is go ahead and write a function here, and it's just going to be called func1 here. I'll pass in some value here. And all this function is going to do is print out our value. So let's go ahead and do something like this right line value and something of this nature here. Okay. And I'll go ahead and just call this with some value, about 42, like so. Let's go ahead and see if this works, and it does. Okay, so this is fine. Now, interestingly, if I take a look at this program and I ask you to think for a moment, is this function changing states here? Some sort of global state outside of this function here. Okay, so let's go ahead and try this out with an experiment by putting pure on our function. Now I could put it here in front, or I could also put it on the back here, pure. And let's go ahead and give it a try. If I go ahead and compile this, we will see that we get an error here. Okay, so let's go ahead and read this error and try to decipher a little bit here. I'll go ahead and move off the screen here. It says error pure function main.func1, so this is part of our module here, cannot call impure function standard stdio right line here. Okay, so that's pretty interesting to me here. And this might be the first time that you're seeing this message or maybe thinking about this. But again, if you're coming from different languages, depending on how much work you've done with things like cout in C++ or WriteLine in Java, it sort of makes sense that how we're writing out information to our terminal here, there must be some buffer, something global that we're writing out to. In fact, this would be some file handle on the Linux system that we're actually just writing out to. So again, we are accessing some shared state here. So again, you could imagine if I had a program with many different threads, and again, this is getting a little bit into concurrent programming, writing out information here, well, we're accessing some shared state here. So we're not allowed to do this. Now there is one exception I'll just briefly show you. You can use debug statements in the deprogramming language. Let me see if I can get this to work here. I believe if I just use the debug keyword here, you can get around this limitation, but again, that's only supposed to be for debug code, so that's just one thing to note. But the idea here is, again, with this pure keyword, and I want to just go ahead and show you that you can move it around here to the front or the back of your function, that you can't access or change mutable states here. So how do we get around this if we want to actually write out this value? Well, we need to be working with things that aren't going to change. And we've learned some of these concepts before, things like immutable or const, if you've been following this series. Make sure you're subscribed, of course. But so what we'd want to do instead is create some sort of immutable data type here, something like this here. Just to quickly put this together. Let's do value, and I'm just going to copy out the string here, concatenate it, And we're going to need a cast here. And again, we'll have to remember how we did casting with the conversion library. And then we'll want to actually return this text here. And I can get rid of this return type here. As long as I have this attribute here, it should infer the type here. And let's go ahead and let's give this a try. Now this is okay. Okay, and then if I want to actually write out this value, I can do it from a non-pure function, which is main here. Okay, so now I can actually, if I define this here, there we are. Then I can actually write out the string that we did here, because this is just returning immutable data. Data that's not going to actually change here once it's created. So the scope is limited because this is just a local variable to this function. We can change whatever we want within this actual function. In fact, you can see that if I go ahead and draw your attention to this example on the right-hand side, where the stuff I have, like I here, which is just some value type that is a new copy here, it is okay to modify it because it's only going to affect this particular invocation of this function here. But as soon as I try to access global state, whether that's write line or a global variable, and we could go ahead and do that example here. Like, let's just go ahead and say we have some global variable here. And I want to do global plus plus. This should give us an error at line 7 here. And in fact, it does. It says cannot access mutable static data global. Okay. Or likewise, if this is a static variable here, let's just go ahead and put it static, something like this, static variable. And let's spell it right here. There we are. And if I wanted to change this here, then again, we're going to have the same issue. Because remember, static is shared amongst all instances of this function. Its scope is reduced, but it's still some value that's being shared. So again, we can't mutate it. Okay, so that is the idea with pure. And again, we could also take this to this extreme if we annotate our main function with pure here. And then effectively, our main function here can't call anything that causes mutation. So you'd have to think a little bit about what this type of program would be here. But again, you wouldn't be able to mutate anything. So it's a strong guarantee. Okay, let's play around with this just a little bit more. And just to kind of wrap things up here, let's go ahead and just create a struct here. I'll create some value here, which will be some member variable here. And then let's also just go ahead and see how pure works with structs here. Okay. And let's go ahead and create a member function that's pure here. I'm just going to call this get value here. Just need something of this nature here. Let's go ahead and try something like that. And we'll make this a little bit bigger here, just so we can try to fit everything on the screen. And again, let's just try to understand how this works. So now let's go ahead and say I create some new struct here. And can I call get value here? Okay. And I can, okay, because I'm not modifying any state here. Let's go ahead and see, can I modify the value here? Okay. So in this case, I can, again, because, again, this value's scope is just limited to this particular member function here, okay? Again, we could put, pure on any side here. We can't use it twice. That's redundant. So let's go ahead and, in this case, maybe use auto. And again, this is fine here. Now, again, let's go ahead and try to modify this just a little bit here. Let's go ahead and, let's do the same experiment where if I have a static variable that would be shared again amongst all instances of structs here. Static member. Now let's go ahead and just see if I do static member plus plus here. So again, I'm trying to mutate state. And again, now I'm getting an error here where I can't make that modification. Now let's see if I could even just read it here. Let's see if I just, had this empty statement. No, same problem here because we don't know if this would be changed somewhere else. So again, pure is a nice attribute that prevents us from making changes here. Now I'll go ahead and just open up the documentation one more time as we close out this lesson here. And let me go ahead and scroll up here just to show you this idea here that we still have to remember some of the things that we learned about when it comes to strong versus weakly pure functions, or strong versus weak purity. And that has to do with our arguments that we're passing in here. So a weakly pure function has parameters with mutable indirections. So these are things like pointers, or where there's pointers behind the scenes, or references, for instance, where we can still modify the program's state transitively, as displayed in this function here. So I'm passing in this array here. I'm modifying each of the individual elements here in our array. I'm adding 1 to them. But the length, of this array is not being modified in any way, but we can see here clearly that we are modifying this function here. Now, strongly pure functions would have no parameters that have an indirection here. So that means we would probably want to mark these parameters as immutable so that they can't, in fact, be changed here. Okay, so in this example, our array itself is immutable and we can't change it. So that's just one thing to be aware of, that we can still change state, but indirectly, and it makes it harder. So we can't forget about some of the things that we've learned about before, like immutable and so on. All right, folks. So with that said, I hope you enjoyed this lesson. Feel free to check out all the lessons on my webpage, courses.msha.io. You can track your progress. And as we proceed further in this series, you'll notice that we start having to combine things like our conversions and functions and structs and so on. So again, it is nice to go ahead and track your progress if you're following along with this series or any of my other ones. All right, folks, and with that said, we'll go ahead and wrap it up here. If you have other thoughts or questions, feel free to engage in the discussion. And as always, thank you for your time and attention. I'll look forward to seeing you in the next one.